So to follow up with question 4 from the notes, I wanted to create a quick video showing you how to do quadratic regression lines, which we've done linear regressions, so it's very similar. So I'm going to walk you through based on your default settings on your calculator. The example is a study compares the speed x in miles per hour and the fuel efficiency of cars in miles per gallon with the data provided. So we want to enter the data and create a scatter plot. Now, for reasons that will show up later, we need to turn on our diagnostics, which means go to second, catalog. We want to scroll down to diagnostic on. I'm going to hit D here to speed up the process. And keep scrolling and choose enter twice and it will say done. Then we want to enter the data into the calculator, which means we have to go to Stat, Edit. Now, list 1 should be your X's, list 2 should be your Y's. For the sake of time, I went ahead and typed these into my calculator. So you may want to pause the video while you enter that in. Now, once that is in, we have to tell the calculator to plot those. So I'm going to second, stat plot. This is y equals, and choose number 1. And I just want to simply turn this on. Now you want to make sure you choose the scatter plot feature. List 1, list 2 are your X's and Y's. Your marker should be the box. Now if you hit graph, you won't see anything. That's because we're outside the window. So we want to hit zoom, number 9, zoom stat, and that will create our scatter plot. I've got some images saved here. I'm going to actually insert this as we go. Alright, so that should be what the scatter plot looks like. Now we want to create a model of the scatter plot, which requires us to go back to stat, go over to calc. Now we've done number 4, linear regression, before. Now we want to choose quadratic, because clearly you can see it has a quadratic trend to the line. So we choose number 5. Hit enter. Now when we get to regression equation, we can have it actually store it into y1 for us. If we go to vars, go over to function, choose number 1, y1. Now it will give us a summary of data. This is the model that we want. Now I turned diagnostics on at the beginning. That was to see this r squared value. And we've mentioned before that this correlation value, the closer it is to 1, the better the fit. So with a quick screenshot here, I'm going to enter all the details for our model here. Alright, so we pretty much use that information to create the function equation. Now that function equation can be used to answer any other questions about speed versus the miles per gallon used. We want to use this function here to determine the optimal speed to maximize the fuel efficiency. Now notice if we go to y equals now, it has our equation already typed in for us. That's convenient. If we want to graph, you can see how well the graph fits the data. Now to maximize fuel efficiency, we need to figure out the very top of this, which we know as the vertex. And so to find the vertex, we use negative b over 2a because of the form that it's in. And again, to speed up the process, I have this data worked out here. And you can see all the details where I've done negative b over 2a, so that you will discover that 45.8 miles per hour is the optimal speed, which will actually give you 30.4 miles per gallon.